So we've seen that if you have polar coordinates, then you can always recover your x and y pretty easily, because the x is going to be r cosine theta and y is going to be r sine theta. So that's just obvious from the picture here. If this is the angle theta and this is the distance you're walking out, r, then this is x and y, and so we get those relationships just from our basic trigonometry. Going the other way, so these are great if you have r and theta, right? You have polar and you're trying to convert to Cartesian equations. Going the other way is just a little bit trickier, because if you have the x and y and you want to find r and theta, there can be multiple representations. The two things that have to be true, though, looking at this picture, is that the tangent of theta has to be equal to y over x, and from the Pythagorean theorem, r squared has to be x squared plus y squared. But both of these equations have multiple solutions. In particular, if you solve this second one for r could be either plus or minus x squared plus y squared. So there's not a unique choice for what r needs to be. The same thing here with the tangent of theta. You know that if you have an angle and you add pi to it, it will have the same tangent. So there are multiple angles to consider. Now, if you decide to always work with a positive radius, then here's a set of equations that you can use, but keep in mind that they're not the only possible answer. So you could limit yourself and say that if the radius has to be positive, you're going to guarantee that you're going to be walking forward from whatever direction you're facing, then you could just use the plus sign there. And then you could say that theta needs to be the arctangent of y over x. There's one problem with this, though. The arctangent is always between, we choose the usual branch for the arctangent. We choose it so that theta, the angle that comes out of the arctangent here, is always between minus pi halves and pi halves. So this isn't going to quite work, particularly if you have a point over here. If you insist on having a positive radius, so if you know you're going to have to be walking forward to that point, then the angle you're going to have to be facing is going to be outside of that range. It's not going to be between minus pi halves and pi halves, right? So here's what we can do, though. On the arctangent, if you're actually over here where the arctangent can't give you an angle, because the arctangent always gives you an angle in the first or fourth quadrant, if you're over here, you'll know you're over there because x is a negative number. Now, if x is a negative number, then you know that when you take the arctangent, you'll actually get the angle over here. So because you'll find the one that has the same ratio of y to x as the one you're looking for, but that is between minus pi halves and pi halves because of the restriction on the arctangent. So you know you're going to get an angle over here, and to fix it, you can just add pi. So what we're going to do is sort of adjust this formula a little bit. If x is greater than 0, then we can go ahead. We know that arctangent will work, so we'll just take the arctangent of y over x. But if x is less than 0, let's see, then what we can do is we can take the arctangent of y over x and we can add pi to it so that it will adjust it, so that it will be over here in the correct quadrant. The same thing would happen over here, right? If you had an angle, you needed to have this angle over in the third quadrant. Arctangent would actually give you the one in the first quadrant, and you just adjust by adding pi. So if x is less than 0, that's definitely what's going to work. Now we got to think about what happens if x equals 0. Well, if x equals 0, you're going to be either having an angle of pi halves or negative pi halves, right? If x is equal to 0 and y is greater than 0, and you're trying to use a positive radius, then the angle is going to have to be pi halves. But if x is equal to 0 and y is less than 0, then you're going to have an angle of minus pi halves. I guess there's one last case. If x is equal to 0 and y is equal to 0, so then obviously you're at the origin, right? So you could choose any theta. So definitely no unique representation of the origin. So anyway, these are the equations that must hold. If you insist on having a positive radius, you will get a specific value for r from x and y. So given x and y, you could find a specific value of r, and then you'd have to, and you could also use the arctangent to find theta, but you'd have to adjust it if you had an angle that was over in the second or third quadrant by adding pi to it. Let's look at an example. This is a problem from the book. It says find the polar coordinates, and they give us a specific range on theta, so they lock us in, and they require that we use a positive radius to represent these points. So these are all Cartesian points. When we see these, we know that that's xy, 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 and so on. Okay, so if we have to have non-negative radius, then for the first one, r squared equals 4 plus 4, so r would be the square root of 8, since this is 8, which would be 2 root 2. And then if we look at this angle, we're going back 2 and down 2. So theta, according to what we just said, would have to be the arctangent of y by x, which is -2. That's the arctangent of 1. But that would give us an answer in the first quadrant, so we need to add pi to it. The arctangent of 1 is pi fourths, so we get pi fourths plus pi would be 5 pi fourths. So we know that -2, -2, one representation in polar would be 2 root 2, and the angle could be 5 pi fourths. Of course, that's not unique, but it is, it doesn't even fit the requirements here. 5 pi fourths is more than pi, and they asked us for an angle between minus pi and pi. So what we could do, though, is subtract 2 pi from this. So you have 5 pi fourths, and you take away 2 pi, which is taking away 8 pi fourths. You have -3 pi fourths. So we should give the angle -3 pi fourths in that case, so that we would have theta in the correct range. Okay, so with these ranges, that locks us into a unique answer. Without the ranges, though, there could be multiple answers. We could take this angle and add any multiple of 2 pi to it. Also, we could rotate 180 degrees and walk backwards, so we could add any multiple of pi to this as long as we use the opposite radius. Let's look at B here. So, since we're walking 0, 3, right, we're just going straight up, we can see that obviously the angle needs to be pi halves, and the r value is 3 as well. So in polar, this is 3 pi halves. That satisfies both conditions, so we've got it. Okay, so let's see. Notice that using the arctan is not going to work for you. You could use the arc cotangent to pop that out. So the arc cotangent of 0, right? So okay, would give you the pi halves. Arctangent is not going to work because you have to take the arctangent of y over x. That's undefined. But you can just see from the picture what the angle needs to be. Okay, this one is, we're walking back root 3 and up 1. So -√3 and up 1. So to find r, if we want a positive radius, we can just take the square root of x squared plus y squared. If you square x in this case, you get 3. Y squared is 4, so the radius is equal to 2 in this case. Now we've got to find this angle theta that we need to turn in order to be facing that location. So if we do the arctangent of y over x, that would be the arctangent of -1 over root 3. But because of the definition of the arctangent that we use, this is going to be an angle between minus pi halves and pi halves, so we need to rotate it by pi in order, so it would give us this angle if we did the arctangent. So we'll just add pi to it. So we get this negative angle, we add pi to it, we get the correct theta. Let's see, the arctangent of -1 over root 3 is -pi thirds. So we get -pi thirds plus pi gives us, it's -pi sixths. Plus pi gives us 5 pi sixths. So our representation of this in polar, the radius is 2 and the angle is 5 pi 6. So we have a radius that's non-negative, and our angle is between minus pi and pi, so we've gotten it. Okay, what about D here? We have this point we're walking forward 5 and down 12. Okay, so we've got this location here. So we can calculate the radius. If we want a positive radius, we can do the positive square root of x squared plus y squared, which is going to be the square root of 25 plus 144, which will be the square root of 169, which is 13. So we know in this case that the radius is 13. Then the angle is going to be the arctangent of y over x, so the arctangent of negative 12 over 5. Now the arctangent always gives you an angle between minus pi halves and pi halves, and in this case, because the tangent was negative, you know it's down here in the fourth quadrant, and so this is going to be the correct angle. There's not a nice representation for this angle. You could plug it into your calculator and get a decimal approximation, but that's the exact value. So we have the radius of 13 and an angle of arctangent negative 12 over 5.